My name is Wycliffe, and in this session, I want to share with you how you can obtain temperature data for your region of interest. Say this area is your region of interest, and you want to see how the temperature varies between the urban center and the areas that are outside the city. All right, so for this, we will use Landsat data. So Landsat 8, collection 2, level 2, tier 1, this one. Okay, so we will copy this snippet and then we go to our RStudio. Okay, so in RStudio, we load the library RGE, and then we also load the library MapEdit, which enables us to draw the boundaries interactively. Okay, then we, as usual, initialize our R session or our session connection. We make connection with the Google Earth Engine servers, and then we can now draw our region of interest, which we use draw features function from RGE, from MapEdit, and then we use SF. We convert that SF object to an Earth Engine object, okay? Now we can zoom to our region of interest. Let me put this satellite background so I can easily detect it. And then I draw a bounding box. You can have your own region of interest layer, or you can draw a polygon of any dimension, okay? Then once we have our region of interest, then we can center our object around the region of interest. So center object around region of interest. Okay, so that's the Earth Engine object, region of interest, and then our zoom level maybe 12, okay? Then we get the Landsat data, which I already copied. So to that snippet, I will just say our Landsat is that object, okay? And then after getting the Landsat, which is that, then we filter bounds only for the Landsat images that have ever been gathered around our region of interest. And then we filter for the date, and that's only between maybe for 2024. So we say 2024, January 1st, all the way to 2025, January 1st. So that's 1 year. And then we get the median for this period, right? For this surface temperature, let's ignore the cloud effect because we are using the band 10, okay? Then this image, if you look at it here, you will realize that, I can fully open it here. You will realize that for the bands, we have this band 10, which is surface temperature band. It's written surface temperature, and it has got some scale factor, which we need to use to reduce the digital numbers to reflectance values. And then it is in Kelvin. So we need to change it from Kelvin to Celsius, okay? So after getting this median image, then we can say our Landsat in degrees Celsius is the original Landsat. And then after taking the original Landsat, we multiply it. We can even already select the band. So we only select one band, which is STB10, surface reflectance band 10, and then which is the surface temperature band. And then we multiply it by the scale, which was 0.00341 and then 802. Okay. After multiplying by that, we again add a number which was 149. If you remember the numbers we were seeing here, that number and this number, those are the numbers I'm using to multiply as the scale, and also the scale and the offset. Okay, so the offset we add to the scale after scaling. Okay, And then we convert the Celsius to Kelvin to Celsius. So to do that, we need to subtract 273.15. So 273.15, we subtract from that image, and then we can rename the final product. Instead of calling it STB10, we can call it land surface temperature, LST, okay? Then we finally, we only filtered it initially, so we can now clip it to our region of interest. Something is not right. Maybe I didn't run this, then this. Okay, something is still not right. Okay, subtract. Perfect. Okay, so we have our Landsat image in Celsius covering our region of interest, which we already digitized. So we can already visualize it, okay? So we can see how our the temperature values, the median temperature values for this period of time in our region of interest look like, okay? So that we can do by map. Did we already center object? Okay, we already centered. So we can just go ahead and add layer. And the layer we are adding here is the Landsat in Celsius. Landsat in Celsius. And then visualization parameters, or how do we make it more appealing to the eye? We provide a list for that. And inside the list, we give I have experience in this region, or I've lived in this region, so I know the maximum and the minimum temperature ranges, maybe 36 or 38 or so. Minimum around 18 or 12 sometimes, and maybe maximum of 36. That is extreme cases. And then we can provide a palette of maybe blue for the cool regions, very cool regions, green for generally cool but moderately warm, yellow for warm, and red for the hot, not really hot, but quite warm areas, right? Okay, so, and we can call it surface temperature. So that gives us the temperature layer or temperature map of our region of interest, right? So we can, of course, see that city or urban or town center is generally warmer than the outskirts of the city. When we go into the farms, the temperature gets cooler and cooler. But if you are inside the city, it's way, way, way warm. And this, the bit of the idea behind urban heat island, like in urban areas, temperature is generally warmer. You can imagine of all activities taking place there, the land cover, surface reflectance, or reflectance is not that high of the incoming solar radiation and all that. So generally, urban areas are warmer than the neighboring agricultural land areas or farms, okay? So I just guessed this based on what I know about this region. So for your case, you might be interested in getting the actual minimum values. So we can say minimum temperature. For this region, we will use the Landsat Celsius, and then we reduce region. Okay? So the reducer, for example, for this case, we will use the minima. So because we want the minimum temperature. And then for the geometry, we'll use the region of interest. And then, And then I know the scale is 30 meter for this image. So this gives us a dictionary, which is Earth Engine object. So from this, we can get info. So that will give us the LST and that, and then from the info, we can just get the LST. So that gives us the actual minimum temperature value, 15. It's actually 15. So my 12 was not right. So we can bring that to the to the mapping, and then we can also get the maximum temperature, which we only change the name and the function. Okay. Then we can bring that again to the max temperature. First of all, let's check what it is. 36 points. So I missed with 0.4 something. Okay. We can add that, and let's see the visualization again. Yeah, thank you so much. That's what I wanted to show today. If you want to use this code for your own analysis, you can grab it from my GitHub repository, of which I will leave a link in the description of this video. Remember to cite the sources of data you use as well as the packages. For this, I think there is a citation, terms of use. Okay. Terms of use, read all this information so that you know how freely you can use the data, and also description of the data to know what level 1 and tier 2 and all that mean. Okay, thank you. Enjoy coding. Bye-bye.